I'll be taking on the topic limit of a function. Okay, limit of a function. Limit of a function. All right, let's take the mathematical definition of limit of a function. Let's write limit of a function can be defined mathematically as a function f of s. Limit of a function can be defined mathematically as a function f of s gives L as s approaches a. Can be defined as a limit of a function of a function can be defined mathematically as a function f of s gives L as s approaches to a. So we can write this mathematically, can be written at full stop there. It is written as this. Written as limit of f of s as s tends to a is equal to L. This is the mathematical definition of limit. Okay, so what does it mean here when we say s tends to a? It means s is equal to a. So anything you input here as s equal to a will give you a particular value. That value might not be a, it might be any other value. Please take note. Okay, so we are going to understand this in our example, in our questions. Okay, so but before we solve any question here, please write a note here. Let's take a note here. Note that limit of a function is basically on the principle, sorry, is basically on the principle of sorry is basically on the principle of substitution. Okay, please note this, that the limit of a function is basically on the principle of substitution. Okay, so we are going to know what principle of substitution is. Okay, but before we know the principle of substitution here, we have to know the method of solving units of a function. Remember, the first thing here is to know what limit of a function is, and we represented the mathematical definition of it. The next is to take a note to know the base of limit of a function, and is basically on principle of substitution. So now let's take the method we can use to solve, or we method of solving limit of a function. Okay, you can write method we have method of solving limit of a function. The first method here, we have three methods, okay? The first method here is direct substitution method. The second method here, class, is factorization method. Okay, we use this for indeterminate limit of a function, for indeterminate limit. Okay, we are going to know what indeterminate limit is. All right, we use this factorization method for indeterminate limit. So the third one here, that is the last one here, 3, we have rationalization method. We use this for sodical fraction, like when we have fraction that consists or comprises of a sod, we use rationalization method. Okay, we use this for sodical fractions of limits. Okay, now these are the method here, class. The first method is direct substitution method. The second method is factorization method. We use this for indeterminate limit, while the last one here is a rationalization method. We use this for fractional sodical limit. Okay, so when we have a fraction that consists of sod square roots, we use this method here. Please take note. So now let's consider the first one here. Okay, that is direct substitution method. Now listen to me carefully. All limit of a function can be solved on direct substitution method. Listen to me carefully. Before you determine the method of limit of a function, the first method to use to determine if it is determinant, the determinant method, or if it is determinant limit, sorry for that, if it is determinant limit, or the sodical limit is determinant also, the first method to use is direct substitution. Please take note, is direct substitution. Okay, so let's do it on direct substitution here. Please write direct substitution. Direct substitution method. Direct substitution method. Okay, direct substitution method. Now this is what you should understand here, that the definition of limit is this limit of, sorry for this, definition of limit is this limit of f of s as s tends to a is equal to L. So this is the definition of limit. What does it mean here? This s tends to a simply means that s is equal to a. So it means that anywhere you see s in this function here, you replace that as a, and it will give you a particular value. Please take note. That is what it means here. So to solve any limit, please take note of this. To solve any limit at all, the first method or the first approach to use is direct substitution method. Please take note, okay? So let's solve a question here to understand properly. Question one, let's solve. Evaluate ln of s squared minus s minus 12 over s minus 4 as s tends to 3. Okay, now this is the first thing here. This is the first question given to us here. So class, whenever you see, listen to me carefully. Whenever you see any question on limit of a function, the first thing to do or the first method to use is direct substitution method. Okay, now each of the method, I'm going to review the secret or the unique difference between them. Okay, but whenever you see any question on limit, the first thing to do is to use direct substitution. Okay, is the direct substitution that we review if the limits can be if the limit can be solved using direct substitution, or if the limit can be solved as indeterminate limits. Okay, why? For rationalization is very simple. Whenever a fraction consists of surd, you can use rationalization. Okay, very simple. Okay, so now let's try to use direct substitution here. So when we say something like that, s tends to 3, it means that s is equal to 3. So anywhere I see s here in this limit or in this function here, I replace that as 3. So I will have something like this, class. I will have something like this. I'll have something like this. 3, sorry, 3 all squared minus 3 minus 12 over 3 minus 4. And my answer is said to be 9 minus 3 minus 12 over minus 1. Remember that 3 minus 4 give us this here. So 3 all square is not the same as 3 times 2. It means repeat this 3 into 2 times, you have this. Okay, now 9 minus 3 minus 12 give us minus 6. So I will have this to be limit of s square minus s minus 12 over s minus 4 as s tends to 3. I will have the answer to be minus 3 at numerator, so minus 6 at numerator over minus 1. So the minus will cancel. I will have this as 6. So this is my answer here. So this is the first approach you do whenever you have any question on limit of a function. Okay, the first approach or the first method to use is direct substitution. Okay, so let's solve the next question here. That is question 2. Let's solve the next question here to perfect this. That is question 2. Question 2 is exam possible question. Question 2. Okay. Evaluate limit of 1 plus sine 2s over 1 minus cos 4s as s tends to pi over 4. So these are the options here. A, 1, B, 1 over 2, C, minus 1 over 4, d 1/10. Okay. Whenever, listen to me carefully, limit is very simple. The more we go, the more we identify the difference between the direct substitution method, factorization method, and rationalization method. Okay, all you just have to do is to hit the subscribe button and you get all the classes on limit of a function and exam series on limit of a function. Okay, so now let's consider this. So this question here is on limit, and the principle of limit is basically on substitution method, that is substitution. So I have to replace it. Means this s tends to pi over 4 simply means I should replace s as pi over 4. Please take note. So replacing that, anywhere I see s here, this s, I will replace it as pi over 4. Anywhere I see s here, this is s, I will replace that pi over 4. Now let's do that. I will have this to be class limit, first of all, solution, sorry, solution. Okay, I have this as limit of 1 plus sine 2s over 1 minus cos 4s as s tends to pi over 4. So now let's replace. I will have this as 1 plus sine of 2 into pi over 4 over 1 minus cos into, sorry, 1 of 4 into pi over 4. Please take note. So class, let's simplify this. The next is to open this bracket here. So if you open the bracket here, of course, this 2 we cancel this 4 we cancel this. I'll be left with 1 plus sine into 4 pi over 2 over 1 minus cos into pi. Please take note. Okay, now there's something you should understand in terms of pi, that is this pi here. Please listen to me carefully. There's something we have to know in terms of pi. Now, when pi, listen to me carefully, when pi is representing a number, the value of pi at that point will be 3.142. When pi is representing a number, the value of that pi will be 3.142. But when pi is representing an angle, the value of the pi will be 180. So we are going to know when pi is representing number or a value, or when pi is representing an angle. Now, whenever you have pi aside the front of a trig are sine, cosine, tangent, cosec, you know them, okay? If pi is at the front of trig, that is, this pi here is at the front of trig, we call it an angle. If I have something like this, sine of theta, this stuff here at the front of trig is an angle. So if pi is at the front of trig like this, is an angle. That means the value of this pi will be 180. But if pi is not acting as an angle, if I have pi as this, pi sine theta like this is not at the front of trig. So since this pi here is not at the front of trig here, that means the value of this pi here will be 3.142. Okay, let me come again. Okay, let me come again. Okay, whenever pi is acting, whenever pi is at the front of trig, sine, cosine, tangent, it means that that pi is acting as an angle and the value will be 180. But if the pi is not at the front of trig, if the pi is not at the front of trig, that means that pi is acting as a constant and the value is 3.142. So this pi here is acting as an angle. It's at the front of this trig here, that is sine. It's at the front of this trig here, that is cosine. That means how we take our pi at this point to be equal to 180 degree. Please take note. So replacing 180 degree there, this is going to be equal to class. I'll have this to be equal to this will be 1 plus sine of 180 over 2 over 1 minus cos of 180. So punch your calculator. 180 over 2 give us 90. So this will be 1 plus sine 90 over 1 minus cos 180. So let's punch our calculator. Sine 90 will give us 1. Cos 180 will give us minus 1. If you replace that, will have the answer to be this. If you do that, we'll have the answer to be this. That is limit of 1 plus sine of 2s over 1 minus cos 4s, as s tends to pi over 4. We'll have our answer to be this. That is 1 plus 1 over 1 minus into minus 1. Remember, we are still working on this guy here. Sine 90 will give us 1. That is this one here. Cos 180 will give us minus 1. That is this minus 1 here. So our total answer here, class, will be equal to 2 over 2. Minus minus is plus. 1 plus 1 is 2. So this guy, cancel this guy. Our answer will be equal to 1. Okay. So this is how we solve limit by direct substitution. Okay. So in our next video, I'll be teaching on the next method, that is factorization method. All you have to do, hit the subscribe button to get notified for the next video. Okay, thank you so much.